Going to work through problem 4.47 from chapter 4 of Taylor's Classical Mechanics. This is an elastic collision. It's a head-on elastic collision between two particles. And we want to prove that the relative velocity after the collision is going to be equal and opposite to the velocities before. So you have two masses. So we call this one M1. This one is M2. They're traveling at each other head-on, so we're only a one-dimensional motion right here. So you're going to have V1, V2. After they collide, you can have mass 2 and mass 1 traveling in V1 prime and V2 prime. So we want to show that V1 minus V2 is the exact equal and opposite equivalent of their final velocities. So this is what we're trying to show. Now, the approach that we're going to take is similar to if you watch the solution for 4.46 or you've worked through that question, the one right before this, using kinetic energy. We know that's going to be conserved. So we're going to have M1 V1 squared plus M2 V2 squared equals M1 V1 prime squared plus M2 V2 prime squared. Rearranging this, we get M1 V1 squared minus V1 prime squared equals M2 V2 prime squared minus V2 squared. So this is going to become important in a moment. That's using kinetic energy. Now, just like in 4.46, a method for going about it is using momentum. So we're going to use momentum. So this means that M1 V1 plus M2 V2 is going to be equal to M1 V1 prime plus M2 V2 prime. In a similar way, we're going to go ahead and rearrange this. So we're going to have M1 V1 minus V1 prime equals M2 V2 prime minus V2. You notice these equations have some similarities. We're going to go ahead and divide this top equation by this. So I'll write it out. Over M1 V1 minus V1 prime equals M2 V2 prime minus V2. That's actually going to go down in our denominator. Prime squared minus V2 squared over M2 V2 prime minus V2. Alright, these masses are going to go away when we divide. Now you notice this is a perfect square, or it's not a perfect square, but we can put it into two sets of binomials, multiply it out. So you're going to have V1 minus V1 prime times V1 plus V1 prime over that V1 minus V1 prime equals V2 prime minus V2 times V2 prime plus V2 over V2 prime minus V2. Now you can see these are going to cancel out. You're going to divide out of there. And we're going to end up with V1 plus V1 prime equals V2 plus V2 prime. manipulating this equation, we'll get V1 minus V2 equals V2 prime minus V1 prime, which is what we set out to show. This is the same as negative V1 prime minus V2 prime. This is exactly what they wanted us to show at the beginning. Wanted to show that V1 minus V2 is equal to negative V1 prime minus V2 prime, where V1 and V2 are the initial velocities and the V1 and V2 prime are the corresponding final velocities. Because it is the negative of those, we show that the reaction is exactly equal and opposite.